Are you ready to find out how much air your lungs can hold? We will momentarily. In preparation for this lung capacity lab, you're going to need something to write with. You will need the balloon and a metric ruler. We are going to be measuring in centimeters. You will need the instruction sheet. That includes the graph for balloon diameter, the data sheet, and height and age estimates for vital capacity. Make sure you have all your things together and then join me. Let the fun begin. All right, let's introduce this lab. Without a continuous supply of oxygen, rich air, the air we breathe is about only 20% oxygen. The body's cells cannot function and death rapidly occurs. In the respiration process, the cells produce carbon dioxide, a waste product that must be expelled from the body. In a sense, then, the living body relies on the constant exchange of gases, oxygen in and carbon dioxide out. In the simpler forms of life, single cells or clusters of cells do their own breathing by direct diffusion. Oxygen is absorbed into the cell through the cell membrane. Carbon dioxide exits the cell in the same way. In man and in more complex forms of life, those animals we've been studying all year long, the cells which ultimately use oxygen and produce carbon dioxide are not directly exposed to the atmosphere. Being separated from it by tissue membranes like the skin and bones, the respiratory system is the means that this gas exchange takes place. An additional system, the cardiovascular system, is essential for the transportation of oxygen between the respiratory organs and the body's cells. The heart pumps oxygen-rich blood through the arteries to all parts of the body and receives back via the veins the used oxygen-exhausted blood, which will be renewed or reoxygenated by the lungs after the carbon dioxide has been expelled. This life-sustaining exchange of gases, approximately 18 exchanges per minute, involves an intake of roughly 12,000 quarts of air per day. Divide that by 4, it gives you gallons. All right, let's talk about the lungs. The lungs, in conjunction with the bronchial tubes, trachea, pharynx, and nasal cavity, are the major elements of the respiratory system. Before birth, the lungs are not inflated and only become inflated as the newborn infant takes its first breath. From that moment on, breathing is synonymous with living. Lack of breathing is dying. The more polluted the air, the more the lungs are susceptible to disease. Lung disease is one of the leading causes of death, and the lungs can be the prey of several different types of disease, all of which ultimately inhibit breathing and the proper introduction of oxygen into the system. Among the serious diseases of the lungs are cancer, tuberculosis caused by the bacterium, emphysema caused by damage to the alveoli, which decreases the surface area of the lung used for gas exchange and causes shortness of breath, and overstrains the heart, and then also pneumonia. In this lab, you will measure the lungs' tidal volume, vital capacity, and estimate overall respiratory health as a function of the vital capacity. All right, so make sure you have your things together, and we're going to get started. All right, so as we begin, I just want to remind any students that actually have a lung condition to be careful doing this experiment. We want to make sure that you remain in good health even though you're doing this experiment. Our first experiment 1, we are going to measure tidal volume in the lungs. And this is just your general sitting there, breathing, you're in your chair, you're standing, you're working, just your normal breathing. Now, a couple things that we need to do before we get started is you need to blow the balloon up a couple of times to soften it so that it will be easier for you to do this step of this experiment. So I just like to blow the balloon up and kind of squeeze it a little bit so that it softens up the latex. All right. Now, that was step one. Then you're going to inhale normally and exhale normally into the balloon. Do not force your breathing. Then you're going to pinch the end of the balloon and you are going to measure it. Now, if you look at the picture here, you want to make sure that you might have to push the balloon a little bit. You want it to be as round as possible when you measure in centimeters. And then you will use this table right here. Based on the centimeters, it will give you a reading of how many liters that is, and you will be recording that on table 1 under trial 1, title volume. It says balloon diameter. You'll write that down, then you'll write down the volume from the graph. Okay, so let's see how this works. And we're going to do this 3 times. So sometimes it helps if you just think, okay, I'm sitting here relaxing. You do kind of have to push a little bit to get the air out of your lungs into the balloon. Now, sometimes I like to take a twist or two so that I can see what I have. All right, let's take a look and see how many centimeters we are here. All right. This looks like 15 centimeters. So I'm going to write 15 centimeters down here. And then I'm going to go over to my chart and I'm going to look at 15 centimeters. I'm going to find the cross line and it says 1.5 liters. Okay. Trial 2. Again, we'll take a look. Sometimes if you can hold it behind the balloon, you can look over the top of the balloon. I'm at 15 centimeters again. And that will also be 1.5. All right, last trial. Here we go. This one's 16 centimeters. So 16 is now 2 liters. Okay, so you'll add those up and divide by 3 and get your average. Okay, so now we are going to measure vital capacity. This is listed as experiment 2. This is how much your lungs can really hold in a jam when needed. So it says, repeat the above procedure. Only this time, inhale as much air as you can and exhale forcefully. Record 3 measurements on the data table and then convert the diameter to a volume using the graph and record this in table 1. Okay, so this is where if you have asthma or another lung condition, you're going to want to be careful with this one. All right, so when it says exhale, it is all the way out. Okay, so here we go. Let's see what I can do. Wow, that doesn't look much larger. Well, let's find out. All right, so that is 18 centimeters. And 18 centimeters corresponds to 3 liters. All right, let's try this again. Okay. Whew. There we go. And we have 18.5. And 18 and a half, well, that means I got to go between the 2 lines and come up to where it meets the line. I am at 3 1/4 liters. Last time. There we go. What did we get? We got 19 liters on that one. All right, so, excuse me, centimeters. There's nobody with 19 liter meat. That was 3.5. Okay, go ahead and pause the video while you do your calculations. Are you ready to find out how healthy you might be in your lung department? So you have just finished calculating your average centimeters for both tidal volume and vital capacity, and you have averaged your liters for tidal volume and lung volume. What I would like you to do is on vital capacity, circle your average in liters right here in this box right here. Circle your average in liters for your vital capacity. Now we are going to fill out this table 2. We're going to take a look at overall health. It says, estimated vital capacity. Research has shown that the capacity of a person's lung is proportional to the surface area of his or her body. Using the chart below to determine your estimated vital capacity in liters using your height and age, then you're going to record that on table 2 under your estimated, which is going to be the second box. And then you'll calculate your percent of predicted vital capacity and then use the information to the right of table 2 to determine your respiratory fitness and record that information in table 2. Okay, so you're going to need this chart right here. And so for me, I've marked mine in. The age group starts at 20. So you're going to choose that age group right there because you are probably very close. You're within 5 years of that. I am choosing in between my 5-year bracket for my age. So when I did my average, I got 3.25 average VC in liters. Then I went to my table over here, and I am right between 2.4 and 2.3. They say as you get older, your lung capacity kind of goes down. So I put that in the second box. I rounded it to 2.35 because it's right between those two. And now what you do to calculate that, it says the percent of predicted, the number that you got from this table, and divide that into your average. So you take your average on top, the predicted on the bottom. You're going to do that division problem, then multiply it by 100, and you will come up with a percentage that you are going to use to match your fitness rank right here. And my fitness rank, I'm happy to say, 138%. So I fall greater than 120. I fall in the high category. So I would be predicted to be in good lung health, good lung fitness. And as you wrap up this lab, you want to make sure that you have completed the 6 questions in part 1 And you have also completed the part 3 closing questions, of which there are 5. And when you have all this information together, you have completed this lab. And hopefully it'll allow you to set some goals for your lung fitness in the future.